this test talk. The topic is the discussion of a seminal research paper entitled Towards a Framework for the Certification of Reliable Autonomous Systems. We're joined today by one of the prime authors of the paper, Dr. Holger Schlingloff, Chief Scientist and Head of the Systems Quality Center of Fraunhofer FOKUS in Berlin. So welcome, Holger, and I'm delighted you could join us for this test talk.
Hello, Peter.
He is the Chief Scientist of the Systems Quality Center at the Fraunhofer Institute of FOKUS. He has more than 15 years of experience in testing of automotive systems with most major OEMs, Daimler, Volkswagen, Opel, Audi, and others. He has also worked with Tier 1 suppliers such as Bosch, Siemens, IAV, Carmack, and Panasonic. He also works with the Daimler Center of Automotive Information Technology Innovations in Berlin, and his main interests are specifications, verification, and testing of embedded safety critical software. His areas of expertise include quality assurance of embedded control software, model-based development and model checking, logical verification of requirements, static analysis, and automated software testing. How did you get involved in the quality assurance, quality engineering field of research?
Well, as a student, I started off with philosophy. As a young person, you want to understand how the world works. And I quickly got into formal philosophy, into logical reasoning. And then I switched into computer science, and I applied those logical reasoning to computer science problems. So that naturally led me to verification and quality assurance of software. And that's where what I continued to do. So that's why I'm today.
Your paper that you participated in proposes a framework for the certification of reliable autonomous systems. And the paper involves scientists from many countries, the United Kingdom, Italy, US, Germany, New Zealand, and Lebanon. How is this team assembled, and why is this international participation important?
Well, we have in Germany a wonderful institution, which is the Castle, which organizes seminars. And these seminars are by invitation only, and they usually involve an international community. And there was a seminar on autonomous systems, and there were people from all over the world, virtually all over the world. And within this seminar, we formed working groups on specific topics. And the working group I was involved with, we decided to give the results of our discussions into one paper and to publish it at a conference.
And the problem that you selected to work on, how did that evolve, and what is the problem that the team is trying to resolve?
Well, the seminar itself was on autonomous systems, so many of the authors or many of the people in this seminar were dealing with construction of autonomous systems, whereas I have a background in quality assurance and verification and testing. And so I suggested to have a working group also on these issues. And so we thought about what does it need to make a system reliable, to verify it, to test it, if it's autonomous, if it's working on its own.
Having read the paper, I could see this is not a simple problem, and it requires a lot of work to be done in order to certify a reliable autonomous system. So in setting the context, can you help with some definitions? What is a reliable autonomous system, and what role does verification, testing, quality assurance, and certification play in determining reliability?
Well, talking about reliable autonomous systems, there are two notions which need to be defined here. One is, of course, the notion of reliability, and the other is of autonomy. An autonomous system is one which works without human intervention, without a human operator, which helps or manipulates the system. And a system is reliable if it provides the functionality whenever it is necessary. Think about a reliable phone network or a reliable autonomous car, which is available whenever you need it.
Holger, your paper describes many challenges facing certifying reliable autonomous systems. And I'll mention just four. But there are many in the paper expressing the difficulty and the challenges facing the certification, verification of these reliability for autonomous systems. And I'll start with that at the time of this writing, there were no standards regulations, apart from BS 8611, that address truly autonomous systems. That current standards and regulations are not ready for coping with autonomous systems. That moving from written standards to formal specifications that can be fed into tools able to check, verify, and certify the system's behavior is not possible. Software certification is so challenging that the adoption of the same method or tool across different domains is often impossible. So it seems like this is almost an impossible situation to certify. And your team proposes a 3-layer autonomous framework of reaction rules, principles to deal with these challenges. How did you come up with this model, and why do you think the model is robust?
This is a very central point of the paper. Naturally, we had a long discussion on that, how we should distinguish these 3 layers. And let me comment a little bit on why we have these 3 layers. So the lowest layer is the reactions layer. That would mean the direct reactions to a sensory input. Think of, let's say, a vacuum cleaning robot which hits some floor and then it turns around and moves away. And for a human, that would be more comparable to, let's say, physical reactions. If you touch a hot surface, you withdraw your hands. There's not much thinking about and not much information processing. And then the rules layer is that you learn how to follow rules. In the vacuum cleaning robot example, a rule would be that it tries to cover the whole floor and vacuum the whole floor. And with humans, of course, we all have a lot of rules when driving a car. Also, there are traffic rules like one-way signs or stop signs and so on. Above all these 2 layers is another layer, which in humans we would say is that of natural intelligence, or where you say, okay, sometimes there are situations where you have to not follow the rules in order to achieve some better result. If there's a stop sign and there's, for example, an injured person which you need to get to, you would not follow the stop sign. So you would override the rules and do something reasonable, common sense reasonable. And that is something which most autonomous systems nowadays do not yet implement. But imagine a self-driving car coming to a roadblock where it needs to pass to the other side of the road in order to be able to advance at all. So it needs something like this, and we think that currently this is not sufficiently cared for in the evaluation.
As you described, there is this differentiator between rules and principles, and what you're looking for is how an autonomous system needs to reason whether to violate the rules using ethical reasoning. Can you describe the state of ethical reasoning, and what types of ethical reasoning standards are universal versus regional to create a consistent set of principles? Isn't that a difficult problem?
Yes, it certainly is, and this is where also we are not definite in the paper. So it is very hard to come up with universal principles which are acknowledged amongst all humans, and even harder for universal principles for all autonomous systems. However, there is a chance autonomous systems are designed, they are not evolving, and so we can try to adopt a universal attitude here.
And then you point out in the article that one way we might address this for autonomous systems is the way that we address it for humans. And effectively, we should consider in the approach for certification applying the same or similar requirements for humans, such as licensing, assumed human characteristics, human systems interface, relevant regulation and laws. Can you amplify on the licensing or applying human regulations, as it were, to autonomous systems?
Sometimes I have the feeling that our expectations of machines are exaggerated, that if we want, for example, autonomous cars, they should behave absolutely flawless. Nowadays we have like more than 1 million deaths on traffic accidents per year, and if there's a single accident caused by an autonomous vehicle, then this is worldwide in all papers. So we need to make sure, of course, that the autonomous vehicles are to the best possible, but we cannot expect that they will never have any problem. And so we suggest to have something like a driver's license for autonomous cars, and we should say that it's sufficient if they behave, let's say, as safe as human drivers, or let's say 10 times as safe, but it's not reasonable to assume that they are absolutely always correct. And for example, a driver's license for an autonomous vehicle, of course, would also involve exceptional situations where, let's say, there's a kid jumping in front of the car and it needs to brake, or there's some traffic accident and it needs to behave adequately. So that should be, of course, included, but we would not expect an autonomous system to behave absolutely flawless.
The proposal of a 3-layer model that you then used in the paper 7 different examples in different domains to validate the hypothesis. You also point out the many challenges in research, engineering, and regulatory that need to be resolved. Can you amplify on those challenges and how they might be overcome?
Well, we distinguished between these 3 application groups, let's say. Of course, we knew a lot of scientific questions in research which we want to address. For me, the most important question is how do we even specify what a moral responsible behavior is? Once we have specified things, we can try to reason about it and try to put this into systems or into computers and programs. On the engineering side, of course, the engineers need to do this transformation. Once we know what we want to achieve, then there are methods and engineering practices which can be followed. But for autonomous systems, there are no such practices yet established. So there are lots of engineering challenges. And then on the regulatory side, you already mentioned that there are no standards and procedures which regulators have to follow. So this is a political discussion also, what can be done and what needs to be approved here in order to make these systems available to humans.
Given the challenges you've raised and the velocity of the development and introduction of autonomous systems around the world, how will standards and regulations keep up to this market reality? Will the adoption of the proposed 3-layer framework and its implementation be in time to protect the public interest?
So this is an important topic which you raised. So we are in a real concrete danger that so-called industry standards emerge, that industry pushes systems into the market which the society as such does not want. And so regulators are called into action here to come up with standards and methods to validate that the systems are according to human needs and not to industrial needs.
Well, it seems like there's be a real risk of that not being addressed in a timely fashion, and it could take a long time to get to the level of certification that's being proposed in your paper. Is that a worry for you?
Yes, indeed. You're completely right. So there is a huge speed here in the development. Systems are coming out every other month or so, and we need to make sure that the societal needs are also reflected, and that systems are in a way such that they can be used by humankind.
So Holger, I was struck by the three-layer principles, rules, and reactions. And my question is, don't the OEMs need to design their systems into those layers, rules, reactions, and principles in order for their software to be certified? And how difficult is that going to be?
Yes, I would definitely support that. Currently all requirement specifications, especially in the automotive domain, are structured, written in a form, if this and this is the case, then this and this should be done. So this is purely as reasoning on the rules level, but it comes from the reactions layer. And this is not adequate for the ethical layer. In the ethical layer, we do not have this, if this and this and this, then do that and that and that. Because you cannot specify what an exception is, what an exceptional unforeseen situation is. So in order to verify that, we need this structuring.
And along those lines, different countries have different rules related to certification and verification. In Europe, there is often a requirement a third party is involved to validate and verify that certain software complies with certain regulations. In other words, an independent third party. In other countries, Canada being one, there are more guidelines and there's no third party independent verification required. So to get to the certification of reliable autonomous systems, would that require some harmonization of regulations internationally?
Well, probably. There are international regulations, but especially for this ethical layer, I think many principles are the same in different countries. And so I think you mentioned that the separation of concerns, that the developer should not test their own software. With autonomous systems, in particular if they are learning while they are in operation, this distinction does not exist anymore. So we need completely different ways of approaching this problem.
I want to raise something in the conclusion of your paper, which is the last sentence. It basically states, should the autonomous vehicle have self-defense capabilities against humans? Can you amplify on this concluding remark?
Of course, this sounds a bit provocative. Let me tell you a story. I work with a company which produces transport robots for factory automation. And I was standing in this factory, and along comes a transport robot, and it beeps, and there's a human and smoking a cigarette, and just not going away. And so the machine is always a slave. The human has the command here. But what humans also do is that they sabotage these systems because they know that in the end they might take away their workplace. So what the system, of course, it should not have self-defense, but a machine should be able to record and collect whatever is happening in the environment.
Thank you. What do you see at this point as the next step in the promotion and communication of this proposed framework for certification of reliable autonomous systems? What needs to happen?
Well, of course, we need to have a discussion in society on what level of autonomy we would like to have. Self-driving cars are around the corner. They will be available. What level of confidence do we need with these cars? What other tasks do we want to delegate to machines, and what is the role of humans after all?
In terms of how our audience should react, or if there are listeners that want to get involved or would like to learn more, how might they, where would they go, and how might they help?
Well, I assume that there are a lot of engineers listening, so they might want to read our paper, and when they're designing autonomous systems, they might want to structure their software more according to these three levels. They might think about the ethical layer, because often this is just neglected, and try to separate the layers for verification. If you're just a user, you would like to know, think about how much would you want a machine to interact, what do you want a machine to do, how much trust do you put into a machine, and do you have alternatives or do you have backup solutions?
So thank you very much, Holger, for joining us for this test talk. It's been a great discussion, and we really appreciate your participation.
Thank you for the invitation, and I hope we can continue our collaboration.
For our listeners, if you would like access to the papers that we've been discussing in this call, you'll find it on our website, and there'll be a link to the papers there, and you can access it directly.